everyone. Welcome to this first session of linear algebra where we will focus on particularly vector. Let's look at today's agenda. What we will going to cover now. Well, first of all, we want to show some basic of history of linear algebra, application field of linear algebra, vector, and how do we actually use vector in our machine learning using Python language. First of all, in the ancient time, for the first time, Chinese used first the linear algebra, and later on in Europe, 1637, the system of linear equation introduced with them. After a quite long term, the Hermann introduced theory of extension that is called today's linear algebra. So application of LA. Well, before moving this, I want to show something about that. Linear algebra is broad topic. Today's world, we can say that without this mathematical base, so we cannot like imagine. There is everywhere we can see linear algebra. If we pick up the statistics, if we pick physics, then you can show that linear algebra available. Well, some of folks maybe know that math is not required, or there is no much thing required for machine learning. But I want to say you that without linear algebra, ML is thinking impossible. So we can see some application field of linear algebra. First of all, mathematics in engineering, such as line spring, graph and network, analyzing networks, also linear programming, the simplex optimization method, and also Fourier analysis, moreover linear algebra for statistics, uh, and computer graphics such as visualization, image reshaping, rotation, so and so forth. All here linear algebra exist. So well, so why linear algebra is required for machine learning? Well, we can say that, or in our universities, linear algebra is prerequisite for machine learning course. Why? Because the it's called the mathematics of data. Okay, why we have to know some basic idea about linear algebra? Before going to describe this, you can I share with the 10 common field where LA strongly related. First of all, data set and data file, image photograph, on hot coding, linear regression, regularization, deep learning, and so on. How it's important? Well, if we open any data set, for example a CSV file, we can see here some rows and column, and sometimes there we can see that it has numeric value, string value, or sometimes it can be store any object. So our machine uh, cannot find anything or cannot understand without number. So how do we number? For example, one hot encoding, in a data set, like it has uh, a column where it has month, so we know that 12 months. So 1 to 12, the number range is limited, so we can give them if January, then we notation it 1, February 2, and so on for the December 12th. So whenever the imagine we have thousands of data set in our data, in our data set it has 1000 data. So so we can repeat it whenever find January, we can convert it into one. So machine learning, whenever he knows this is the number one month, number two, he never understand this is the January, this is February, and so on. So image and photograph, one of the most vital thing nowadays. The computer vision, we all are familiar with that. If you are don't know, so whenever we insert any input to the in our model, we talk about perspective all about machine learning. So uh, machine it converted into a 2D array. For example, the image is grayscale, otherwise basically the image has three channel, means that RGB. So all colorful pictures are RGB, and gray pictures are 2D. So for simple understanding, converted into 2D, and where the value range 0 to 255, this number represent actually image. And later on in the deep learning we will know how LR mm, strongly connected, or the equation how helped we all see when we are watching the artificial neural network model or convolution neural network model later on. Before I going to the hands-on code, I want to say another thing is that Numpy. So as we are, our journey is about math, machine learning. So here we have to we use the programming language Python, and we know the all mathematical stuff handle NumPy. So I'm not deep dive into NumPy today. I just introduced that whenever we show the some code on Google Colab, how do we handle it? We just see here the n dimension array, and you all are familiar with this. This is 1D and this is 2D. So you can forget it. You can just consider it as like your what you say matrix. So vector. Today's our prime focus is vector. What is vector? Whenever the name vectors come in terms of math or physics, in physics we all study about that vector. It has a specific direction and it has a value. But in terms of math, like in machine learning, do you actually consider this like we have direction and it has own value? Well, we will see uh, on the hands-on way. Okay, so mm, okay. First of all, we draw in space. Okay, we all know that the axis about, and here is the origin. Draw it, and the ups and down. So whenever in the x-axis the all positive is here, and when the x-axis negative number we all see in the left side. Similarly, whenever we have any positive number for y-axis we go up, on the other hand we go down. Okay, I hope it's clear to you. Okay, so let's see how actually a vector, or we know that. So in each element of vector, it is a component or coordinate. What does actually mean component or coordinate? Well, for example, we have a vector like this. This is say a vector, and here we also have another direction. It's called b. So if someone asked us that what does it mean, or how do you add this? Well, look at this. Can we draw direct line like this? Okay, maybe you think this is very simple. We can draw a vector actually. No. Why? Look at this. This is the number line. We all know that there is the negative value start from end from minus infinity, and here is the positive infinity. Okay, so first one, consider this is from goes to like 3, so we go 3 first. Okay, then we have 2, like this one is 4, so our start journey from here to 4. Okay, so this is also 4, so 3 4 7, like this vector actually addition work here. So what we have to do for this, well, so how do we draw this vector actually? Okay, I copy paste it here for simple understanding, better understanding actually. Okay, I just, okay, we have to wait, the eraser is not work. Okay, in the meantime, I again recall you that in physics, what we know when we have vectors. Okay, so vector has length and direction. There is not, you can see the direction. Okay, I don't know actually why it is not working. Okay, so it's worked now. So what do we do? Instead of we draw the line like this, we add, for example, this is 3 that we earlier show, and from here, like what is the coordination of, just for we give say minus 3 1, and this coordinator is like 2 1. Okay, and this is minus 1 3 because this is the downside. Already I told you that the y value in the below, it represent the minus down, and here all the positive x. uh, Start from here, like this is 2 and this is 5. First of all, we draw this 2 1. Okay, then we have to actually like this value for 1, and here we can see this is the negative 1, so this positive 1, this negative 1, so actually the vector end up here. Okay, and this is the summation of a plus b vector. Okay, I hope you understand it. So how do we calculate in other way? Okay, for example, if you find some difficulties, let's make it very simple. The coordinate of a is 2 1. Okay, and okay, I made a mistake here. Actually, this one is goes to upper. Okay, we just consider this is 2 2, then okay, 2 1 just remain, and here is the b. So how do we write the b matrix in the box here? 3 minus 1. Okay, So in our simple addition, we all know that how to add it, is not it? Okay, just 2 1, and we can write this. Add these two, we will get the number 5, and from 0 here. Okay. Okay, we saw the how it would like. Well, consider it can be replace the number with any variable name. So if you 1 x 1 plus x2, on the other hand, you got it. Now I want to like to share two things that already you know that this is vector. Basically we represent here column vector, you can say. So should we have any row vector? Yes, definitely. This row vector is like 1 2 3, and the column vector is like 1 2 3. Already we deal with the column vector stuff. So another interesting equation I would like to share you. So vector represent like this is vector, and this is normal variable x. Whenever we have, you can see this, the arrow sign above it, so consider this is an vector. So whenever we transpose the vector, the transpose, yeah, is the came from the matrix. In the next session we will see the matrix operation. So this is like when we transpose we got the y. On the other hand, similarly, if we transpose y, then we will got x vector. Remember these two things. Okay. So now move on to the linear combination. What is actually linear combination, or where we can see this application? When addition and multiplication together, it called the combination. It means that the addition and multiplication exist here, and this is the more important or crucial part that is we can see in our artificial intelligence or machine learning. The linear combination basically works. So how it works? Okay, before we go to the deeper look at this, -5, we all know how to plot the value. If this is origin, then this is the -5 and 2. Okay, the plotting is done, is not it? So the question is now come, how do you add this, like this or other way? Well, so these two -5 2, then we go here, not start from here. This is different one represent. So we goes here 5, then 2, then we can connect it. Okay, so this is our vector I, j vector, and this is our direction. Okay, I hope it makes sense. So where, what is 5 and what is 2? This is scalar. So what does the scalar means? For simple things, scaling, like this is the length or two length a red line. I want to uh, stretch it from 4, so 2 to 4. So how we perform scaling? Or on the other hand, this length is 4 length, so I want to divide it, reduce the size. How do we perform the scaling perform we all here? Okay, for simple understanding. So another one is the span. What is span? Okay, okay, here one. What is span? Well, we all know that now. The vectors means a coordinate or position value. For example, if we point here, like this is minus 2, 2, 1. So this is a point. Also, this is any point. So point can be here, point can be here, point can be here. So what does the span mean actually? Span means all the possible vectors is span. If we move it, we can see the 2D span, uh, like here, its number can be here. Okay, there are a numerous vector available, like this minus 2 can be here also. So whenever it here, it goes to like this. For example, it can be point here, it can be here. Like we want to change the value. Okay, simply like how do you make this minus 2 1 to 1 5? Okay, so when a vector can be defined a linear combination of other vector, how do you define it? Okay, if we find the determination, if the determination value is 0, then we call that the one vector is depend on another vector in terms of linear combination. On the other hand, if the determination is not 0, then we cannot define it the set of linear independent vectors. Okay, dependent and independent, which like for example, this a vector is dependent with the b, if the determinant value is 0. If not, then it is not. Okay, if the determination is not 0, then we cannot define that is the set of linear independent vector. Now we look at this, the linear combination example, how it is. Okay, so this is my new vector. I want to drive this from x and y. This is my x value and this is y value. I want to find this one. So how do I find this? Well, first of all, if I addition these two, okay, so minus, so the result will be minus 11 and 1. So where my required value is 13 minus 3, but instead of this I got minus 11 1. So how do I do this? Okay, I have to change this vector in a way, and also similarly this vector too, such as whenever I do any addition, then I can we can solve it in three way. One is graphical, which means the plotting two value and we find them from the intersection value. Second one is substitute method. Third one is elimination method. You can go through any one, whatever you would like most. One give more comfortable to me. So multiply like something that it can change the value. So I introduced the a. What does actually a? This is a scalar, nothing. Value v is also scaling. You can also say that I want to perform scaling or decompose, like uh, reduce the value, change the value. One word is change the value. Okay, so whenever I multiply this one, change the value. Okay, look like this, like okay, simple. Okay, now what I have to do now? Well, for simplicity, I can write it like 14a plus 5b minus 2a mm, minus b. Okay, I made a mistake, little mistake. Minus 14 to, okay, and this is plus 2. Okay, I have to clean it. Okay, so this is equal to like my new vector is minus 13 3. Okay, so what we have to do for the elimination process, we can consider this one is equation 1 and this one is equation 2. So if we apply elimination method, we want to eliminate someone, like consider the b. So if we multiply these 5, positive 5 and negative 5b will be banished. Okay, so the equation number 1 is similar, there is no change. If we multiply this, we will got like this and 15. Okay, so as it is elimination method, so this one out, we got like 2. This is 4a actually. So what actually the a value, which equal to zero point 0.5. So if we 0.5 insert here actually, then what we will go, we will find the value of b is equal to negative 4. You can check it on your, or you can also use the substitution method and check this. Okay, so now back on our code, actually how we handle the vector in linear algebra. I mean, how linear algebra use in the Python code. Okay, so in linear algebra, a vector can be represent a tuple, or you can call it is a list. How do we just uh, input the array from the numpy. Okay, if I define this, I will show the value. Okay, it takes time for connecting, so whenever it's okay, then it will start run. Okay, is not it? So vector arithmetic, we know that how to define a vector. Okay, so if you want to change this one like this, the value will be changed. So this is the simple way to define any vector. So we want to show the vector arithmetic operation. Okay, I back onto the uh, page here, like where we can add the vector. So in here we can see this, the vector first we go to, then we go through rest of the value. So here actually we do not like maintain any direction, rather then we just simply define a vector and b vector for our general equation, this actually work inside. Individually, this one is first vector, second vector, third vector. Okay, you might be confused. I just comment out this and I run this. So if we add this 1 1 2 2 2 4 3 3 6, simple. So same things, I just want to multiplication, I just insert here. The sign is different from, you can also perform the similar thing, substitute. Okay, we see what does the substitute perform actually. That